Good morning. I am Shailendra Singh Ojha, Assistant Professor in Department of Electronics and Communication Engineering. Today we are going to discuss differential amplifiers. So what are differential amplifiers and what is the need of differential amplifier and their working? We will discuss these today. As its name suggests, differential amplifier means a device, an amplifier which can amplify the difference of two inputs. If once the term differential input is arrived, that means we need two devices whose input, how we can get the difference? Difference can be achieved, or we can get a difference if we will have two quantities. So, to having two inputs, to having two quantities, we should have two transistors. So, we can connect two transistors which can work as a differential amplifier. So, depending on this, there are four configurations of differential amplifiers which can exist. One is differential input balanced output differential amplifier, another one is differential input unbalanced output differential amplifier, single input balanced output differential amplifier, single input unbalanced output differential amplifier. In this way, we can categorize differential amplifiers into four parts. And another thing is why we need differential amplifiers. The logic is somewhat simple, and we will prove it by mathematical analysis also, that differential amplifiers have the capability to reject noise. I will explain, or I will discuss it with the help of diagrams. You can see this is the dual input balanced output differential amplifiers. In this differential amplifier, you are providing two inputs and output is the difference of these two inputs. So, due to this, we are calling it as dual input and balanced output. Dual input unbalanced output, that means you are providing two inputs, but you are taking output from either transistor Q1 or from Q2. This is single input and balanced output. You can see that you are giving input at the transistor 1 and input of another transistor is 0 because you have connected it to ground. And the output is the difference of output of two individual transistors. So, this is single input unbalanced single input balanced output. This is single input, it is 0, and unbalanced output. You are taking output from the transistor Q1, or you can do output from transistor Q2 also, but it will be 0. So, the concept is simple. How these differential amplifiers are categorized, it depends on the combination of inputs and outputs. That means, if you are giving two inputs, it is called as dual input. If you are taking output as a difference of two individual inputs, output side is called as balanced output. If you are giving input at the transistor Q1 or Q2, then it is known as, or it is named as single input. If you are providing input at both the transistors, it will be named as dual input. So, there are four combinations: dual input balanced output, that means you are providing two inputs and you are taking output from the two transistors. Dual input unbalanced output, that means you are providing two inputs and taking output from either transistor Q1 or Q2. Single input balanced output, that means you are providing input at transistor Q1 or Q2, that means at one transistor and taking output from two transistors. If I will talk about the fourth one, that is known as single input unbalanced output. That means you are providing input at either transistor Q1 and Q2, and you are taking output from transistor 1 only. Now, let us see what is differential amplifier and how does it look like. So, this is the diagram of BJT differential pair. There is one more circuit that is called as current mirror circuit. It looks somewhat similar to that of current mirror circuits, and generally students get confused. The reason is generally 2 transistors are used in case of current mirror circuits, and 2 transistors are used here in case of BJT differential pair or MOSFET differential pair or any kind of differential amplifier. You can simply differentiate between current mirror circuit and differential pair. One difference is, in case of current mirrors, you can use minimum 2 or more than 2 transistors, but in the case of differential amplifier, you will use only 2 transistors. Another difference is, you can recall current mirror circuits, you can recall basic current mirror circuit, you can recall circuit with improved performance like Wilson current mirror circuit, Woodlar current mirror circuits. All of them provides output current and you are not giving any kind of input signal. And in case of, because our purpose is to get constant output current from current mirror circuits, and in this case the purpose is absolutely different. Here the purpose is to get the amplified output, that is the difference of the signals which is applied at 2 inputs. So, this is how you can simply differentiate between current mirror circuit and BJT differential amplifier or differential amplifier. So, let us simply analyze this circuit. What is happening here? This is transistor Q1, transistor Q2. This is the constant current source which has been applied for the biasing purpose, power supply. We are considering that 2 inputs are applied. Actually, this is the basic differential pair. Later on, we will discuss it with the help of DC, with the help of AC. We'll discuss differential mode, we will discuss common mode, all. So, in this case, the current which is flowing in the ammeter of Q1 is IE1, this is IE2, IC1, IC2. Okay. And differential amplifier, I think you have studied operational amplifier. If I will talk about the internal structure of operational amplifier, then their first stage is the differential amplifier. So, differential amplifiers have several applications. One of them is, these are used in operational amplifier, in the designing of operational amplifier. So, if you will see, this is what? This is the differential pair with a common mode input voltage. In this case, you can see differential mode operation is there. How? Let us come to this. Same voltages are applied at the 2 inputs. So, this is called common mode operation. Okay. It is represented by common mode voltage. However, this voltage can be any voltage. It can be 2, 3, 4, whatever. We have simply represented by VCM. Same voltages are applied at base. So, that means equal base current is flowing. That means equal emitter current will flow in transistor Q1 and Q2. So this current I will be equally divided between two transistors. So this current will be I by 2. The current which is flowing in the emitter of Q2 will also be I by 2. And you know IC is equal to alpha IE. So this will be alpha I by 2. This will also be alpha I by 2. And the voltage drop across this resistor RC will be equal to RC into alpha I by 2. So the voltage at this point will be VCC, this voltage, minus the drop across resistor RE, that will be alpha I by 2 into RC. So this is VCC minus alpha I by 2 RC. Let us analyze transistor Q2 also. In this case, same current is flowing in emitter I by 2. So this will also be alpha I by 2. And voltage drop across this resistor will be RC into alpha I by 2. So this will be VCC minus alpha I by 2 RC. So if you will take actual output, that will be the, let us consider this is V output 1 and this is V output 2, and it is equal to V output 1 minus V output 2, and it will be 0. Now you may get surprised, what is the need of this type of circuit, this type of amplifier which is providing you output equal to 0, even you are applying input. So how it can be amplifier? Actually, we have not analyzed fully. We have considered particular case, that is common mode operation. In case of common mode operation, yes, it will provide output equal to 0 even if we are applying input. And this is not a drawback, this is the advantage. See how. Earlier I told you that differential amplifiers are used for the rejection of noise, used to minimize the noise, used to eliminate the noise, whatever you want you can say. See, let us consider this device. In this case, noise will affect equally. Try to understand. Noise will affect equally to both the transistors. That means output noise will be 0. Even if the noise will be applied, we are not going to apply. It will be either internally generated noise or other kind of noise. So whenever noise will affect these two inputs, that means at the input noise is there, but at the output noise will be 0. So this is the advantage. And for the amplification of signal, we will never apply same signal to both the inputs. We will apply in this way. Actually, this is the differential pair with large differential input. We are applying, let us consider we are applying some voltage at this transistor and this input is 0. So whole current will flow in Q1, let us emitter current is I, it will be alpha I, and this output will be VCC minus alpha I RC, and this 0 0. So it will drop will also be equal to 0 volts. So whole voltage will get here. So what will be the output? We can consider like that, V output 1 minus V output 2, and so in this case actual output will be equal to minus alpha I RC. Now you can see that we are getting output. So this is the concept behind the differential amplifier. So this is that kind of amplifier, that means this is the differential input with opposite polarity. In previous case we considered this voltage was equal, this input was equal to 1 volt, in this case it is equal to minus 1 volt, and this is 0. And this last one is the differential pair with a small differential input signal, that we will discuss. So now the concept is clear about the differential amplifier. What is the need of differential amplifier? This is amplifier, or these amplifiers can cancel the noise or minimize the noise. How? We have seen in case of common mode operation. Okay. Let us consider now fourth. This is the fourth case, which is of the differential pair with a small differential input signal Vi. We have applied a small voltage Vi. Earlier, I/2 current was flowing in two transistors. If we have applied Vi voltage, then it will draw more current, and the current which is flowing in ammeter will be equal to I/2 plus delta I. Obviously, the current which is flowing in the ammeter of Q2 will be equal to I/2 upon I/2 minus delta I. Why? Because total current is I. If in this case plus delta I is flowing, then in this case minus delta I is flowing. And this plus delta I and minus delta I is flowing due to a small Vi which we have applied at the base of transistor Q1. Now, I/2 plus delta I, this is the ammeter current. Then what will be the collector current? Collector current should be equal to alpha into I/2 plus delta I into alpha. So, the voltage drop across RC will be equal to RC into this alpha I/2 minus delta I for transistor Q1 and plus delta I for transistor Q2. So, if you will find out the voltage at this terminal, it will be equal to VCC minus alpha I RC by 2 minus alpha delta I RC, and in this case it will be equal to, you can write like VCC minus this. So, it will be equal to VCC minus alpha I by 2 RC, and minus minus will become plus, and you will get alpha delta I RC. So, this is the output. One is the output 1 and another one is the output 2. So, the difference will be the 2 alpha delta I RC. I think it must be clear to all of us. So, what does it mean? It means that we have applied some input signal and it has been amplified. If there will be some noise which is affecting both the inputs, and that noise will be cancelled out. Let us see the large signal operation of differential amplifier. That means how does differential amplifier will behave when we will apply large input. This is also after analyzing differential amplifier for large signal, we will come to know the characteristics of the differential amplifier. You know, IC is equal to IS e to the power VBE upon VT, and so we can say that IE is equal to IS upon alpha e to the power VBE1 minus VE divided by VT. You can consider anything. Let us, for example, this is the VB1, this is VBE. These are the standard equations which are applied for the transistors. Similarly, IE will be equal to IS upon alpha e to the power VB2 minus VE upon VT. Let us divide this equation by this. So, you will get IE1 upon IE2 is equal to, it will be cancelled out, VE will be cancelled out. So, it will be equal to e to the power VB1 minus VB2 upon VT. So, we will add 1 on both the sides, you will get IE1 plus IE2 which will be equal to 1 upon 1 plus e to the power VB2 minus VB1 upon VT. This is the simple mathematics. Similarly, IE2 upon IE1 plus IE2 will be equal to this, and you know IE1 plus IE2 is equal to I. See, whatever current is flowing in this and in this, that means in emitters of two transistors will be equal to I. So, if you will rewrite this and all this, it will be equal to I, it will also be equal to I, and the difference VB1 minus VB2, that means the difference of the inputs applied at the base of transistor Q1 and Q2 is called as differential input voltage. So, VB1 minus VB2 is VID. So, you can say that IE1 is equal to I upon 1 plus e to the power minus VID upon VT, and IE2 is equal to I upon 1 plus e to the power VID upon VT. So, if you will plot this, that means if you will plot the graph for IC1 and IC2, you know IC and I are related, IC is equal to alpha IA. The graph which you will get will be like this. For IC1, initially it will be small, and when you will keep on increasing the voltage VID upon VT, it will increase like this, and IC2 it will be like this. Actually, these are the characteristics of the differential amplifier. This is how the differential amplifier will behave when you will apply the input. And the important thing is, in case of amplifier, we need linear relationship between input and output, and it can be clearly seen that this characteristics or these characteristics are not the linear characteristics. So, how this device can be used for the amplification purpose? The reason is simple. See, obviously we cannot use the differential amplifier in these regions for the amplification purpose, because in these regions there is no linearity. You are getting curve, you are getting non-linear graph. But for the small region, see, for in this region, you are getting straight line. So, in this region, you can use the differential amplifier for the amplification purpose. And obviously, this value of input will be very small. So, that particular case, when we will discuss, that particular case will come under the small signal analysis. However, this region is very small, which we can use for the amplification purpose, and this linear region can be increased to more input. See, if you will keep on increasing RE, if you will put RE resistor, if you will connect some resistance in this emitter terminal, then the graph will become like this. If you will keep on increasing RE, you will get the variation like this. So, this is how you can increase the linearity in the differential amplifier by introducing RE and by increasing the value of RE. Thank you.